Hey everybody, welcome to 10 years of ScyllaDB and beyond. So let's get started. I'm excited. I'm Laor. I'm the CEO and co-founder of ScyllaDB. Previously, I founded OSV Unikernel together with Avi and the team. Did the KVM hypervisor, did a bunch of other stuff, which is unknown at the moment. And also, while I'm doing it, I also snowboard, like you see in the back, and I love indoor biking as well. But that's not the topic of the session today. The session today is actually about 10 years of anniversary of ScyllaDB. 10 years ago, we started to write ScyllaDB. It looks like a long time ago, but I still well remember how it's really started. And we like to share that journey with you and also talk about the future and have some announcement in between. There's a common adage that it takes 10 years to write a file system. And if you're among the better developers, you'd say 10 years, no way. I'll have a file system in 6 months or in 9 months, 12 months. And that's true. Actually, in order to start something, you can not spend 10 years, but you can do it in a very short while. But the problem is later on, it's not really stable and it's more better quality. And then you need to earn the trust of the customers. And then you see it's not that complete and it's not that stable. And you do another cycle and another cycle and extend and extend and extend. And boom, 10 years goes like that. So it does take a long while to develop a great file system or a great database. Here we are 10 years afterwards, but it's always good to remember why we started. And I think I still remember why we started. We started ScyllaDB because we were, after Pivot, looking for an idea and we stumbled across Cassandra. And Cassandra was and still is a very good distributed database, but it wasn't efficient. Back then, 10 years ago, it could do million operations per second with a replication with 330 small VMs. When we finish the KVM hypervisor, we can do 1 million raw file system operations in a single large VM. So it wasn't a clear math, but the discrepancy was there. We believed we could do the same database with the same API, the same design, much, much better. And this is how we started ScyllaDB. So let's go through some of the major milestones, and I'll take you over some of our decisions. So initially, even prior to making the full decision of going ahead with rewrite of Cassandra, we started with the extreme design of the shard pair core. Unlike the normal threaded approach with threads and lock, every shard of ours has a CPU, a subset of the memory also pinned together with them in a NUMA local area. And it does the IO, the network, and the storage independently of the other shards, shared nothing. So this is how SysStar started. SysStar is an open source standalone library. It used to write Kafka replacement with Red Panda. It used to rewrite Ceph. And obviously, it's our main engine. After SysStar, we started to develop the core database. Initially, we called it SysStarDB. SysStar is a play on the C and a star sign of Cassandra. We had to leave that name and to get Scylla instead. Also, funny anecdote and funny story how we came up with the name, because we did it in a remote work external voting without pronunciation. So you could imagine the surprise when we discovered that there are multiple ways to pronounce Scylla. Anyway, this didn't stop us. And in September 2015, we went to the Cassandra Summit and launched out of stealth mode. This is us launching out of stealth mode. The main thing was that our database can do 1 million CQL operation per second on a single server. The nice story was that we had to send that graphic 2 months ahead of time. And 2 months ahead of time, the performance was 50,000 requests per second per server. It really wasn't optimized. We were busy coding and finishing all of the calls, the RPCs and the APIs. Only 2 weeks prior to the conference itself, we got to 1.8 million requests per second, and we're happy and pleased. And you can see the latency there. I just noticed that the latency says sub-millisecond for 3 nines of the request. It's actually better than what we do today. What happened? Did we regress? Did we lie back then? No, and sort of a no, because back then we just had the time to launch out of stealth mode and to launch something that we thought it's a beta, but actually it was an alpha. And we only tested one data model, the Cassandra Stress 5 simple blobs, not a real workload. And that's why the performance is even better than what we have today, where today it's much more generic. So through our lifetime, we did some better decisions and worse decisions. One of the not that great decisions was the premature optimization of DPDK to bypass the Linux network stack and use our existing TCP/IP code in order to send things faster, because we were sending really small packets initially with C star, and we saw that the kernel is in our way. But later on, as we evolved, we realized that the database is doing much, much more than sending and receiving tiny packets. It does need to process and to query, and the query language got more sophisticated, that it really made no sense to use the complexity and the less friendliness of the DPDK mode and just use off-the-shelf kernels. A good design decision was to invest in the Linux XFS file system in the development, and we sponsored and defined the development in order to have non-blocking async IO with XFS instead of coming up with our own file system, which of course would require another 10 years or 10 years in parallel. So this was a good one. In 2016, we held our first Scylla Summit in San Jose, California. Pre-COVID was in person. And from that summit, we get this monster scale summit multiple years afterwards. In other algorithms, and there were a ton of them on the field as we improve the database, one that we really like is heat-weighted load balancing. The algorithm improves the performance while you restart the cluster, or more precisely, you do a rolling restart. Because let's say if you do a restart and the node is going back and everything is normal, enjoying the cluster back, still for some reason we saw high latency, as you can see in the light blue in the graph. And the reason was that the cache of that server is cold and it's not warm again. So that's the big problem. And if we immediately start to continue the rolling restart procedure, then more and more servers will suffer from cold cache and performance will degrade. So we changed the client to be aware of the topology and to be aware of the cache utilization, the cache heat. And the client knows how to send the data to nodes that have hot cache and slowly warm up the nodes with cold cache. Normally, you'll do the restart but by a rack at a time or zone at a time. And this way, you'll be protected from this phenomena if you have this algorithm as we implemented it back in 2016. A year came back, and in 2017, we actually had the first revenue after 1.5 years of trying with our alpha beta release. Finally, it became good enough so people would pay us. And we sold to an Eskimo. We sold the database to Oracle. They were one of our first customers. Of course, it got us very, very excited. But later on, we just faced a big mountain of issues of a distributed database. We still have issues from the time of 2017. I bet there are some that are still open. Probably they're not that urgent, or maybe no one cares on those niche cases, but that's a reality of a distributed database development. In 2019, Discord became a customer. They wet their feet with a small workload, which gradually grew more and more and more until it replaced their entire Cassandra fleet. We also launched Alternator, our DynamoDB compatible API, which obviously exists today, and we convert lots of DynamoDB workloads. So we have Cassandra API and a DynamoDB API. We even developed a Redis API. It's super basic, but I'm still loving that API. And we recently demonstrated how Scylla can function better as a cache than Memcache or Redis, whether it's from RAM or from disk. Later that year, in 2019, we began Scylla Cloud, the Git init, with 3 developers. We didn't know what we know today, and probably there's plenty of learning for us to learn with regard to cloud management, which always changes, and more requirements and setups and networking and security, infinite amount of things come from that area. Here, this slide, you can see an example of the stages we went through with the Raft consistency protocol. We use Raft for metadata today, and it's very complete. We continue to develop Raft, but with regard to metadata, we did the whole transition, and our schema is fully consistent, and our topology is fully consistent, and we have fencing with the data once things change. This was quite a journey, years of journey, and we're glad we've done this part. There are a ton of nuggets in Scylla, and I do not intend to cover all of them. One particular one that I like, it's related to design. Like in file system, everything is a file. In a database, everything is a table. And if you need change data capture, you need to trigger it for a base table. And from that point on, all of those changes that go to the base table are listed in another table, which track the changes that the main table is undergoing. And you can just access that CDC table and just consume the changes going there, either directly with our CDC CQL protocol, or by using a Kafka connector. So super elegant design. You can just read, I urge you to read this nice design. There are different milestones. One of them was the first P99 conference in 2021. We wanted to expand beyond Scylla in terms of conferences and bring the audience more flavors of content, not just the end user database usage, but also lots of under the hood. Can be in databases, can be in OS or JVMs or other languages, and that's the P99 Conf, which began very nicely, and now it's bigger than the Scylla Summit or the Monster Scale Summit itself. In 2024, we completed and launched Tablets. Tablets is a major re-architecture that divides the database into chunks of approximately 5 gigabytes. They're really small, and it makes Scylla very elastic. How elastic, you say? You ask? This is elastic. So this elasticity, which I'll soon demonstrate, allow us to be almost serverless. what does this mean, serverless, in our world? Because we do have servers in the back. It's allow us to smoothly move between server families like I4I and IE3N or others. It allows us to change the sizes and to be limitless, to quickly react to different workloads. So I'll demonstrate. In the past, it was more of a remote concept. In the present, serverless and tablets are reality. So let's say you have a workload of 500,000 operation per second. Normally, if you don't use Scylla, you need plenty of database nodes for it. With Scylla, just 3 nodes will be sufficient. So with 3 nodes of I4I 8XL, if I'm not mistaken, you can do 500,000 requests per second with 2 milliseconds. Super. Now, what do you need to do if you need to run 1 million operations per second? You can double the cluster and have 6 of those nodes. In this particular, we have a super nice demo, and it's possible to replay that demo, or you can run it yourself. To add 3 nodes of I4I 8XL. In the past, pre-Raft, pre-tablets, Scylla had to add these nodes node by node serially. So it would take way longer time, and streaming was slow and inefficient and depending on the schema. All of these things are over, and in our new releases, this is super fast. And we can add capacity immediately. The P99, while you stream the data, is affected, but it rises from 1 or 2 milliseconds to 2 to 4-ish millisecond in the P99. Performance is still great. And in this particular case, the capacity was doubled in 10 minutes. There was 1 terabytes of data on these nodes. You need to double capacity, 10 minutes. It's a world record in terms of speed. This was done while serving traffic. So super fast. Okay, so this is an interesting piece. Let's see if you can find out what's kind of unusual here. If you need to do 2 million operations per second now. So like other platforms maybe will require 130 nodes, and some platforms will never get to 2 million. But in Scylla, you can do just 9 nodes. What's unusual? Write on the chat. So in this particular example, instead of continuing with the previous instances, we see that the performance requirements getting bigger and bigger. So instead of using smaller machine or medium-sized machine like before, I4I 8XL, now we just add 3 machines of I4I 16XL, doubles. This is why we have 9 nodes, and from 6 to 9 nodes and not 6 to 12. So we just choose to do that, but you can do whatever. This is how it looks like. The system and the tablet scheduler realize that some of those 3 nodes are bigger than the other ones, so they get double the amount of tablets. That's reflected in the data distribution and also in the request distribution. Latency is still outstanding, between 1 milliseconds for writes in P99, 3 milliseconds for read in the P99. Super fast, again, 10 minutes, like no time, world record. And if you need to double to 2 million, you just double. Performance is super, and you can double and play with your cluster super fast. This was a demo we call the Felipe demo, but you can just go ahead and try it. Really, the combination of Raft and fencing allow us to do super quick and parallel metadata operations to serialize them, but it looks like parallel, unlike before where it was really truly serial and super slow. This together with tablets, together with other improvements that we've done in streaming speed, and there's special presentation about the streaming speed, how we boosted it 30x time, creates this magic and this elasticity. We call it ScyllaDB X Cloud. This is our new tagline, and that's what differs from clusters that have all tablets and are all managed by Scylla Cloud. But because everything is consistent and fast, we can change things under the hood super quickly and super reliably and get you the performance you need or the capacity you need super quick, like the demonstration before. So how it translates to your day-to-day practice. Let's say you have this dynamic workload. Normally you have, this is a graph of time, and we have vertical number of operations per second. So most of the time your cluster may be doing 100,000 requests per second, and for time to time there will be peaks that go up to 400,000 requests per second. Those peaks can be daily or it can be just unexpected ones. In the past, in pre-tablets, pre-ScyllaDB X Cloud, we would tell you, like, look, these gigantic peaks, really hard to answer. You need to provision for the worst case scenario almost, and just reserve all the time static environment with 400,000 requests per second all the time. And boom, everything is efficient. You should be glad and all good. But there's better than this. What we can do with ScyllaDB X Cloud is actually allow you to provision the smaller reserved upfront capacity of 100,000 requests per second. And when you have a peak, as long as it's not that peak response is not a millisecond, but let's say several minutes or beyond, then we can plan ahead and just automatically use the API and consume on demand or consume something we call flex credit and dynamically provision only what you need, and then also decommission it super simply with the API yourself without our involvement, just like that. So this is a big saving that can translate into cheaper TCO. We also launched billing and metering, detailed billing and metering information for you to choose and select the right contract, and also figure out what has happened to my cluster over the course of the last month. So this is one big improvement. We have more. So the more is, one of them is the following. So Scylla used to be really good at working at 100% capacity. Working at 100% capacity, it's not a problem with Scylla. Scylla has workload prioritization. It can prioritize your important workloads and defer some other workloads like compaction or repair, or even some user less important workload we tag with workload prioritization. But what's new now is the ability to use 90% of your storage. So this will give you better TCO as well. What's the secret behind using 90% utilization is the ability to quickly move tablets around and be super elastic. So once you near the end, we can quickly add more and more capacity. So previously, let's say if this was your deployment, let's say you had 15 terabytes of data, and we used to say, okay, at 70% capacity, we always add nodes, because node addition can be is unpredictable. It used to be, and it can take hours or days. So it's too slow, and we definitely do not want you to run out of data. So this is what you used to do. With 50%, we used to give you an alert, soft alert. At 70%, we automatically added nodes. Not only those nodes, let's say if they were big, then the granularity was big. So suddenly you would get like a big node, empty node, and the utilization was even less than before. Obviously, we want the best for you and to have you not to spend money on resources you do not need. So now with xCloud and with tablets, it allows us to be very, very dynamic, and we're targeting 90% utilization. It's easy to add nodes. As you can see, we can double a cluster in minutes. So we can do that, but today the nice thing is the other property is that we can mix node sizes. So if you have an existing i4 i16 Excel, it doesn't necessarily mean that all of your other nodes will need to be that big. We can add smaller nodes and just add exactly what you need. And for example, if we add 2 of them, the system would automatically switch them to a medium-sized node. So we'll optimize the amount of nodes and the utilization automatically for you. And you don't even need to select the specific node. Scylla X Cloud with storage utilization target will do it for you. This is really big, coming from a big simplification and a big TCO improvement. The improvement is there for storage-bound workload with 90% utilization, and for compute-bound workloads with a workload that goes up and down quickly, and you can control them through the API. All for quick ease of use without lots of complexity. So this is xCloud. More things are coming. After 10 years, we have multiple things to launch this year, and there are multiple Scylla presentations in this summit. Go ahead and check what's coming. One of them is incremental repair that we're in the beginning of working on it. It's supposed to be delivered within this year. There'll be 2 sets of LSMs, and one repaired and one unrepaired, and it will be super easy and quickly to finish the repair, which will be automatic as well. Another thing is zero token nodes. Some deployments have just 2 data centers. It's cheaper than 3, but the problem is if one dies or there's a split brain, there's no arbiter, and it's too costly to add like a full-fledged data center. In this particular enhancement, which already implemented in the core, we have a data center with just a single node. That node doesn't have data, 0 tokens, and it just is being used as an arbiter to flag which partition needs to live and which partition needs to die. Some more enhancement we do to recover from majority loss of raft. It's something that you should never experience, because there are many times supposed to be 3 zones and multiple regions, etc. But if something like that happens, we like to make it easy for you to recover, or for us. Some more things in terms of recovery and quality. We're about to externalize APIs for you to play with fault injection and to reboot nodes and to inject some other errors into the cluster and test how your client-side code behaves, and also how our managed service behaves as well. A major future improvement is the move to Raft, not just in the control, but in the data. It's something that we're going to work on this year. And to be frank, I'm not sure whether we're going to finish it and launch this particular feature in GA. Not necessarily because it's that long, but primarily because we're doing other multiple projects. So this might be deferred to 2025, 2026, but not more than that. Another interesting, long anticipated feature is the object store and tiered storage. So we already have S3 access by the core, but it's great, and the TCO is low, but latency is high. So it's supposed to work in conjunction with the local NVMe. The next release, Scilla 25.2, will have native backup and restore using this technology. And later on, you'll be able to do super fast restore using the tablet mode, point-in-time recovery, cluster parking, and tiered storage with time series pattern. This is all planned to 2023, maybe 2025. I'm sorry, maybe a little bit of a spillover will remain. And last but not least, vector search. So we have a specific presentation about vector search and the unique architecture we selected. Bob is best of breed, so we selected something really interesting. Go ahead and tune in to the vector search presentation, and we're going to launch it towards the end of the year in Scylla Cloud. So a ton of things for Scylla X Cloud. I hope everyone will experience it, and we're highly excited with the elasticity and the better TCO and simplification that X Cloud allows us. But there are more things, because we told you, like, we've been developing this for 10 years. Easily we can come up with 10 more years of development and even 50 more years. It's endless. Among the features that we like to work on in the next 10 years, there are multiple, like the obvious one, multi-key transactions and multi-tenancy. And so there are a ton of things that are not written here, like analytics and transformations with UDF, and columnar store, etc. A ton of things. I have highlight here features like immutable infrastructure and automatic large partitions handling behind the hood, and also a new special replication mode. These are all will be enabled by the Raft and tablet together. All of them unlock big ability for us to move fast and change the infrastructure underneath the hood, either with new replication modes, with the way to how to break large partitions automatically. And you should forget how large partitions can be a problem, although even today they're not much big of a problem. And also get to immutable infrastructure. I really like to get rid from upgrade cycles, and just every 2 weeks, just throw the old servers, bring a new one, super secure, super comfortable. And this is what tablets allows us. So a lot to expect in the next 10 years, a lot to expect now, and also just enjoy the rest of the conference. We're delighted to have you around. Thank you very much for listening, and let's stay in touch. Bye-bye.